This video is going to be a little bit different. I'm basically just going to read you a paper that I wrote, just because that's the only thing that I could really think of to do with this. Introduction. In 1935, a paper was published about the mysterious reaction of bismuth and perchloric acid. When added to bismuth, perchloric acid forms a layer that becomes violently explosive when heated. Currently, no one actually knows why this is the case. Recent speculation has been made about what actually causes the explosion. According to some, it could be a bismuth in an unusual oxidation state, for example, +1 or +2, but no such oxidation states have been discovered. Others speculate that it is bismuth oxide perchlorate or bismuth perchlorate, but this would not make sense because bismuth oxide is insoluble in perchloric acid, and therefore it would seem that bismuth perchlorate cannot be produced by the reaction. Evidence that it actually is not bismuth perchlorate causing the explosion. When bismuth oxide is reacted with perchloric acid, it does not create an explosive compound. Instead, there seems to be almost no reaction, and the material formed does not have any oxidizing properties, as would be expected for unstable perchlorates. Another problem is that when bismuth is placed in dilute perchloric acid, it will slowly react to form bismuth perchlorate, and the solution does not have any explosive properties. This is highly unusual and doesn't seem to make sense because when bismuth oxide is reacted with perchloric acid, it appears as if the product is an orange insoluble powder with the same properties as bismuth oxide. Another possibility is that chlorine dioxide is being produced by the decomposition of perchloric acid, and this is what is causing the explosion. However, if so, the chlorine dioxide would be dispersed too fast to build up to the point of an explosion unless the experiment was done on a very large scale. Another problem is that other perchlorates do not have the same effect. Evidence that it is bismuth perchlorate causing the explosion. Bismuth oxide seems to be insoluble in perchloric acid, so this may be why people expect to produce bismuth perchlorate when bismuth oxide is reacted with perchloric acid, but don't actually produce any. When perchloric acid reacts with a metal, it will release chlorine, which can slightly attack the metal and produce metal chlorides. Perchloric acid can liberate hydrogen chloride from metal chlorides and produce metal perchlorates. The reason that dilute perchloric acid does not have the same effect could be caused by the hydrogen chloride remaining dissolved in the solution and therefore preventing the formation of as much bismuth perchlorate. The water could also have a passivating effect on the bismuth perchlorate and potentially hydrolyze it back into bismuth oxide and perchloric acid. Another possibility is that the hydrogen chloride produced can catalyze the reaction of bismuth oxide and perchloric acid, which would not otherwise be possible. Bismuth perchlorate can be more reliably produced by mixing a catalyst chloride with bismuth oxide and perchloric acid. In order for bismuth perchlorate to be produced, there has to be a solvating agent as well as an acid stronger than hydrochloric acid. Now we move on to the overall reaction, or at least potentially the overall reaction. The overall reaction may be bismuth first reacts with perchloric acid to form bismuth oxide, water, and chlorine. The chlorine then attacks the bismuth to form bismuth chloride. The perchloric acid liberates hydrogen chloride from the bismuth chloride, forming bismuth perchlorate. The hydrogen chloride then attacks the remaining bismuth oxide to form bismuth chloride, which allows for further formation of bismuth perchlorate. The net equation is bismuth reacts with perchloric acid to form bismuth perchlorate, water, and hydrogen chloride. It is to note that some of the hydrogen chloride may escape the reaction, which can slow the formation of bismuth perchlorate over time. The excess water can slow or even prevent the bismuth chloride from reacting with the perchloric acid, similar to how water prevents sodium chloride from reacting with sulfuric acid. However, over time, the layer of bismuth oxide and perchlorate will build up and protect the bismuth from further oxidation. When excess water is present, the reaction becomes bismuth plus perchloric acid equals bismuth oxide plus bismuth chloride plus water. Much like with any other reaction, excess water can prevent ions from settling in any particular formation, but rather a kind of soup of ions mixing randomly. There is one small problem. Why doesn't the bismuth oxide come out of the solution when it is insoluble in both perchloric acid and water? And why does the bismuth dissolve in dilute perchloric acid? The answer is that dilute perchloric acid, quote, dissolves bismuth, forming insoluble bismuth oxide perchlorate, or bismutyl perchlorate. Therefore, it actually does come out of the solution in the form of a layer that protects the rest of the bismuth along with the bismuth perchlorate. Water is known to have a strong passivating effect on chemicals that are otherwise unstable.